Hello again, everyone. As usual, I am Buff Bud, and today is an extraordinarily off-brand video for my channel. This is actually just a random, nerdy video that I just wanted to make because back in high school, I discovered some really nifty multiplication patterns and nifty just tricks that you can do with the multiplication of 9s and 11s. And it doesn't seem like too many people know about these. So I just wanted to actually make just a really quick video about this to show people the fun tricks. Now, back in school, you probably learned the simple tricks with the 9s. Let's actually start here. With the 9s, let's see, it's 0 through 10 normally. Some places they'll go 0 through 11. For our case, we're just going to not count 0 because it's kind of irrelevant since it's 0 regardless. But you might have learned just a simple, 9, and then the next one is going to be 18, 27, so on and so on. Let me actually, I believe I can autofill this, right? Yeah. So yeah, if we just quickly autofill this, if you look at it, each digit adds up to 9. And that continues all the way down until number 10 here. After that, then you start getting 2 9s for some of them. Now, for this fun trick here, we're actually going to automatically assume that every number has 3 digits because it'll make things a bit more... No, that is not correct. Boy, I love this. Alright, so I know it looks kind of weird, but for the first couple digits, I'm just going to have to use O's because Google Sheets is not very workable. Oh, wait. No, it needs to be 1. Okay. But yeah, like I was saying, we just need to assume that everything here has a third digit in its hundreds spot. I would really appreciate it if I could... There we go. So let me fill these in. And you guys might start to notice the pattern as well. If not, I will point it out to you. Let me do that. And that. That one. And finally, this one. There we go. Alright. So now you'll notice that the first digit is all 0. But then after this, it bumps up to 1. And then in this next column here, the next number is going to also be a 0. And then the next column is going to be 8. Now if we continue, that's going to be annoying. Whatever. Okay, so then if we continue, the next one is going to be 1, 1, 7. Then the next one is going to be 1, 2, 6. And then the next one is going to be 1, 3, 5, 1, 4, 4, 1, 5. Am I doing this correctly? Yeah. 1, 5, 3. And I should just be able to autocomplete that just for convenience sake. Let's just complete it up to there. Okay. So once again, if you look at it, you'll notice that 1 plus 0 plus 8 adds up to 9. 1 plus 1 plus 7 adds up to 9. And that continues up until this point, in which it is now 1, 8, 8. No, sorry, 1, 8, 9. My bad. And in this case, 1 plus 8 equals 9, and then you have the 9. So, every 11th digit, you will then have 2 9s in the number. But, something else I noticed. In the first column, the hundreds column, you'll always have 11 numbers of the same kind. So, 0, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then you get to ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The next one is going to be 1, 9, 8. There we go. And boom. 11. At this point, now it jumps up to 2. Let's see, that's 2, 0, 7. Then the next one is going to be 2, 1, 6. Then the next one is 2, 1, 5. And so on and so on. Actually, I think I messed up there. No, 2, 2, 5, my bad. Okay, 2, 2, 5, my bad. That one is completely on me. And once again, these 2's are going to continue until you have 11 of them. And that continues constantly. I have not done full research into this, but if I had to guess, it continues up into the thousands, and in the hundred spot, instead of having 0 through 9, then you'll have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you'll have tens. You'll have 11 instances of 10. Then you'll have 11 instances of 11, and so on and so on. And then in the tens column, you'll notice that it'll go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the 9 doubles. And then it goes back to 0, 1, 2, 3, 4, 5, 6, 7, 8, and then the 8 doubles. Then it goes 9, 0, 1, 2, and then that will continue. If you guys can't see the pattern already, every time you reach the next number in the sequence, it doubles. So you'll have double 9, then you'll have double 8, and then the next time you reach 7, it'll be double 7. Then after that, the next time you reach double 6, it'll be next time you reach 6, it'll be double 6. So let me continue this onto this area here. So that would be, let's see, 2, 3, 4. Let's see, 2, 4, 2, 4, 3. Then it's 2, 5, 2, 2, 6, 1. Then it's 2, 7. Let's see, that's 2, 7, 0. Yeah, 2, 7, 0. Okay. Now at this point, once again, like I said, the 7 is now going to double. So it's now 2, 7, 9. And you can continue this pattern constantly. The next thing that you guys might notice is the single digit column is always counting down from 9. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And so on and so on. Not many people know these tricks, and I'm just so much of a geek that I wanted to show these tricks off to people because it's just so interesting. So I mentioned on how you'll have 11 instances of whatever number. Let's see if that continues. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then you get to 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it continues. And like I said, the next time you reach whatever instance of whatever, it will double. So up here we reached 7, and then here's double 6, and then this one right down here would then be double 5, so it would be 4, 5, 9, and so on and so on. Then it would be 4, 6, 8, 4, 7, 4, 7, 7, and so on and so on. Let me just auto-complete this for you guys quick. And there you go. It constantly continues over and over and over. The pattern keeps going on. Not many people actually realize this trick, and I accidentally figured it out back in high school. I was just doodling with numbers, and then I started to notice these patterns. I'm like, that is really interesting. And I just wanted to show that out to everyone. So that is the 9 multiplication trick. I'm sure you guys can probably find an actual use for it. I just like it because it's a nerdy thing. But I'm sure this actually has real world applications. You could probably figure out an easy way to work with it, but whatever. But there's also another trick that I wanted to show you guys with the 11 multiplication table. This one will actually help you out a lot better. Now for this one, it's going to be a lot easier to show in something like Microsoft Paint, or in my case, Paint.net. It's a lot easier to actually write it out this way. So, let's see. So, let's just do 11. Oh, that is horrible. By the way, yes, I am using a mouse, so this is going to be interesting. That is also horrible. How am I? I'm using an eraser. That's how. There we go. So 11 times, and then let's just do the simple one. 11 times 1 equals. Wow, I apologize for my horrible handwriting. You know what? For this part, let's just quickly do this. There we go. Okay, so 11 times. That's not what I meant to do. 11. Come on. 11 times 1. 11 times 2. 11 times 3, and so on and so on. I think I can just simply continue this off. Let's go down to 30. That's fine. So you've probably learned this trick back in school as well. For the simple digits, you just double it. So 11 times 1 is 11, then 22, 33, 44, 55, 66, 77, 88, 99, and then this next one is, let's see if I'm not mistaken, is 101, I think. You know, I've actually never actually dealt with that. Yeah, it's gotta be 101 though, right? Nope, I was wrong. It's actually 110. My bad. I'm not really thinking about that part. But now you get into the fun stuff here. 11 times 11. That one is pretty simple. 121. Then times 12. That one is going to be 132. The next one, shut up phone. The next one is going to be 143. You guys might be able to see the pattern growing right now. If not, we'll continue. 154, 165, 176, 187, 198, and then at this point, it's going to be 209. And if you guys can't already see the pattern, uh, the number that you're multiplying by, if you add that up, you could throw that number into the middle of whatever number it is, and then you'll get the answer. So, for example, times 25, that one's simple. If you take 2 plus 5 and add it together, you'll get 7. And then throw the 7 in the middle of the 2 and the 5, so then you'll get 275. And you guys can look on calculators, go to Google Calculators, look on your phone, use an actual desk calculator, whatever you got handy, and you guys can verify that all this stuff I'm saying is correct. It is absolutely amazing. Now, you guys might have lost me at that point, so let me reiterate it. So, 11 times 25 is what we're going for here, okay? If you take 2 plus 5, that then equals 7, okay? Now, you then take the 7, so, well, let's just write out. So, 2, then you take the 7 from here, then bring it over, and then throw it in here. Let's just put up here, 2, 7, 5. It's really difficult to explain this way. The only other way I've actually been able to explain it to people is actually drawing it out on paper. That's why I attempted to bring this up, but as you can see, it's horrible. But I guess we'll try. So let's try another one. Let's do 44. So 11 times 44. Again, I apologize about my horrible virtual handwriting. I don't have any better way of doing this, so yeah. So, if you take the trick from before, you take 4 plus 4, that is awful, and that equals 8. You then take the 8 and throw it into the middle here of the answer, so then you'll have 484. And once again, you guys can pull out a calculator and look at it to verify that it's actually correct, and you'll find that it actually is. Now let's go into a bit more difficult of one. Let's do 87. So 11 times 87. And now once again, if you take 8 plus 7, 8 plus 7 is 15. Now as you can see, you have a double digit number here. You can't take that whole thing and put it in here normally. So if you just follow simple simple addition skills, then you'd put the 5 in the middle, and then you would add the 1 to the previous number here. So at that point, then you would end up with 957. It's a bit confusing, but if you work at it, you are going to be able to wrap your head around it. But now for the really hard stuff. Once you get into the triple digits, it gets very confusing. So if you do 11 times, let's just do 123, okay? 1, 2, 3. Again, I apologize about my horrible penmanship. It is digital and I don't have any kind of like draw pad or anything to make it easier. I'm sorry. If I had a whiteboard that I could do this on, I would do that instead, but obviously I don't, so yeah. Anyway, so you follow a similar principle. You add these two numbers together right away, which in this case would be 5. So then you'd be left with 11 times, and then it would be 1, 5, basically. So the 5 you would then throw back into the middle, and then the 1 you would then add to here as well. Okay? It sounds similar to the other stuff, but it is a bit more difficult to wrap your head around. So now at this point, it would be 1,353. And now, if my math is correct, I will use my calculator to double check this. So let's see, 11 times 123. And yep, 1,353. So that's exactly what you're supposed to do. Let's try with something a bit more difficult now. Let's do a more difficult 100s. Actually, let me clear all this real quick. All right. My apologies if any of you guys were actually following along. Just go back in the video, whatever. Okay, so now let's do 11 times. Let's do 166. Okay, 166. So again, you take these first two numbers and add them together, which is 12. So then you'd have 1, and then you'd have 12 left over. So you again take the 12 and throw it in there. So the 2 goes right here. The 1 gets added to this number here. And I literally just learned this part of the trick last night. I was stumped on this part for the longest time. So I could be wrong about this part. I will be using my calculator to verify. So 11 times 166. So yeah, like I thought, you'd then take this number and also add it to this. So you're basically adding 2 to this number. Yeah, so then it would be, let's see, that would be 1. Then you're taking this one and this one, adding it to the 6. That's 8. Then the 2 here. And then the last 6 goes right back in. And that is the number that you should get, 1,826. And this kind of pattern continues even up into the thousands. So now let's do 11 times 1,200. Let me erase that quick. 34, just for simplicity's sake, okay? So once again, you're going to add these two numbers together, and that's 7. So these two numbers combined, that is a really bad 4. I'm just noticing that now. Those two combine to make a 7, okay? Now, at this point, you would think the 7 would just be thrown right back in there. Yes and no. At this point, once you're at the thousands, this number right here gets added to this number, and then this number gets added to this number. So what you are then left with is 1,000, sorry, 10,000, let's see, 13,000, let's see, that's 574. And if my math is correct, I will once again check my calculator. 11 times 1, 2, 3, 4. 13,574. So yes, that is exactly what you do, and that just keeps going higher and higher and higher. I have not tested this in the 10,000s, but presumably it'll just keep going. If I had to guess, once you're in the 10,000s, like 1, 2, 3, 4, 5, so then you'd add these, then again, I have not tested this. Let's test it right now. So add these numbers together, and you'll get 9. Now, this part here is a bit interesting. Let's see, so 11 times 1, 2, 3, 4, 5. Okay, so I'm not going to look at my calculator. I'm just going to use that to check it. If you take the 3, I'm assuming you would add that to here, add the 2 to here, then add the 1 to here. So you would then be left with 1, 3, 5, 6, 9, 5. Is that correct? 135,795. Oh, wait, yeah, okay, no, so, I'm sorry, that one is actually my bad. I don't know how I got 6. Let's decrease the size of this. So actually, yes, that is correct then. I just wrote it wrong for some reason. So yes, because the 3 is added to the 4 to make 7. Also, that is a oddly perfect right angle there. Anyway, but yeah, you just keep on scaling this up the more you go with the 11s. And once again, I just wanted to make this video simply because not many people know these tricks, and I'm just so happy about figuring them out back in high school. I don't even know if they're common knowledge, and I'm just a complete idiot. But I just wanted to share this out to everyone out there. If you guys have anything to include, please feel free to let me know. If you guys have any other cool math ideas, cool math patterns, stuff like that, please let me know. I love this kind of stuff. But anyway, this video has gone on way longer than I meant it to be. I wanted it to be like a quick 10-minute video, but that didn't happen. But anyway, thank you for bearing with me on this very weird video, and I'll see you guys in the next video. Goodbye.